Good morning, thank you.
And we got our greatest common factor pull out. You can't see the combination in the chat, we can have a 3R. That is definitely how I would start. Yeah. Oh wait. So if you pull the R out of the 6, that's just a 2. Oh, right. Then that should factor more.
There's a question in the chat about due dates for stuff in Canvas. So let me pull up Canvas really quick and make sure that my due dates are okay. Looks like a Friday, and that looks like a Friday. Perfect. Okay. So for chapter 5, because factoring is such a big deal for both pre-calculus and calculus stuff, I want you all to spend the time figuring things out in this section. So the homework and the quiz are both due Friday this week, not Wednesday. It's totally fine if you want to turn stuff in early, but I'm giving us an extra day so that we have more time to see more examples of factoring in class, and so that you have more time to work through those problems on your own. Yeah, so it is correct in Canvas when it shows that it's due Friday. Okay, should we get this going? I got a couple people who have offered up answers in the chat. Looks like most people found that greatest common factor of 3R to pull out. And if I pull out the 3R, I am looking at R² minus R minus 2. Where you go from there is up to you, right? We can do this with an X. We can do this just by thinking through the factors. Either one is fine. I'm going to go straight to here. and say there are only two things I can multiply together to get that r squared. I need r and r. And there are actually only two things that I can multiply together to get a 2. It has to be 2 and 1. So the only thing I'm checking is which of these terms need to be positive. The minus sign on the 2 means I need 1 positive and 1 negative. And the minus sign on the r means the larger number needs to be negative. And if you wanted to check that, we could always quickly multiply it back out just to check. So if I had r and minus 2 and r and plus 1, I'd get r squared, r, negative 2r, negative 2. And if we put those all together, r squared minus r minus 2, we're good to go. Questions about this one before I move on to other things? Yeah.
So how exactly does the sign with the negative sign or the r like that the bigger number needs to be the negative?
Yeah, so you can decide whether you want to kind of use those rules or guides that I've been talking through. You don't have to, but that minus sign on the r tells me I'm adding two things together and the end result is a negative number. So if I think about those two, if I think about the two things, like let's say it's more extreme and I had, I don't know, like 2 and 7. Well, if this is a positive 2 and a negative 7 and I add these together, my net result is a negative 5 because that negative 7 has a magnitude that's significantly larger than the 2. So which, if this were a negative 2 and a positive 7, and I add those together, the 7 has a larger magnitude than the 2 does. So this is going to be a positive 5. So when I'm thinking about this, I know that that negative r is going to come from adding two things together. And because it's negative, whichever of the things is larger in magnitude is going to have to be the negative number. Now, in terms of why the 2 plus negative 7 works out to be negative 5, lots of different ways to think about this. One is to think about this with a number line that I'll go ahead, I don't know, I'll go ahead and put 0 on here. So if back when you were a little kid, someone might have done this on a number line with you. I have no idea. I would have taught you this way if you were in my 2nd grade class. But that positive 2 says I take 2 steps to the right on the number line. And a negative 7 says I take 7 steps back to the left. So 1, 2, 3, 4, 5, 6, 7. And then we say, oh, I end up at negative 5. So it was like a positive 2 and then a negative 7. But in general, anytime I'm adding a positive and a negative number, whichever one has the larger magnitude is going to determine the overall sign for the answer. That was probably way more than what you wanted, but that's okay. Other questions before we move on to more fun factoring? Yes. Like when I checked my work?
Yeah.
So when we check our work, we're adding all of the pieces in the square. So this would be r squared plus r minus 2r minus 2. And the r minus 2r is what gives me the negative r.
Oh.
So I did that math in my head, but we can absolutely write it out. Other questions before I move on? Dun, dun, dun. Okay. So today I want to talk about a couple of special kinds of factoring that show up a lot. And while we can do this factoring the same way we've been doing the other factoring, we also have some shortcuts that are going to help us out. So if I asked us to factor, and what I gave was x squared minus 16. My guess is that some of you look at that, and that's one that you might immediately say, oh yeah, I know what the factors are. Does anyone happen to just offhand already know what the factors are? So there's a comment in the chat that they're both perfect squares, which is true, which is the hint for the shortcut. If you don't immediately see what the factors are, that is totally fine. I'm going to go through this the slow way, and then we're going to go through it using the shortcut. So if I were doing this with, let's go X style here. When we do the X, the number that I put on the bottom is the coefficient of the X term. But that means that I really need to see this as x squared plus 0x minus 16, because I need to have that 0 there. And then I've got a minus 16. So this says I'm looking for two numbers that multiply to be negative 16. And add up to 0. Well, I know that if they add to 0, they have to basically be the same number with opposite signs, which is why it's helpful to recognize that 16 is a perfect square, because the two numbers we're looking for are positive 4 and negative 4. And it doesn't matter which order we put those in, but I need a positive 4 and a negative 4. So my factors end up being x minus 4 times x plus 4. Just to stay on a roll here. If I had x squared minus 25, the same sort of thing would happen. I don't have that 0x term, but I can kind of imagine that it's there, that I have x squared plus 0x minus 25, which means I would need a 0 and a negative 25, and I would end up with a negative 5 and a positive 5. So I would get x minus 5 times x plus 5. Question already, yeah. Oh, yeah, yes, yes. Mechanically, it's still a 5 and a negative 5, but yes. For consistency, let's make sure we put that on the top. Thanks. Okay, so in general, whenever we have something that works out to be something squared minus another something squared, and I'm just going to put A and B in here as placeholders right now. We call this the difference of perfect squares. Difference because we've got subtraction. Squares because I've got two things. that can be written as something squared. And this factors as a minus b times a plus b. In order for this like shortcut to be helpful, it is important that we can recognize numbers that are perfect squares. So let's just list them out really quick. Technically, 1 is a perfect square because it's 1 squared. 4 is a perfect square because it's 2 squared. 9 is a perfect square because it's 3 squared. 16 is a perfect square because it's 4 squared. 25 is a perfect square because it's 5 squared. 36 is a perfect square because it's 6 squared. I would expect you to recognize the perfect squares up through 13 squared. So 49 is 7 squared. 64 is 8 squared. 81 is 9 squared. 100 is 10 squared. 121 is 11 squared. And 144 is 12 squared. Oh, I said 13. I ran out of space. 169 is 13 squared. And it is going to be true both in pre-calculus and in calculus that your instructors are going to assume that when you see one of those numbers, you are immediately recognizing that it's a perfect square. So it's important to like have those off the top of your head. I definitely would go to 13 squared. In terms of stuff that's going to show up on a timed exam, you should be able to go up to 13 squared. If it's anything higher than that, you're probably working on a homework problem or something where you'd have a calculator. Yeah. So one of the things about factoring differences of perfect squares, this works anytime I can group something as something squared times another something squared. For example, if I had 25x squared minus 16, I can factor this as the difference of perfect squares because I can think about that 25x squared as saying 5x, the whole thing is squared, minus 4 squared. And then use our shortcut to turn that into 5x minus 4 times 5x plus 4. So if I asked you to factor 100 minus 49x squared, get that one factored on your paper. And if you've joined me on Zoom, you can put a final answer in the chat. Okay, I'm not seeing anyone brave on the chat putting an answer in yet. I don't know if that's because we need more time. Yeah, so we can totally rewrite that as 10 squared minus 7x squared. Now I'm going to share that there's this tendency, and this is another one of our, like, our brains do weird things. My guess is that at least for some of you, your brain wants that x to be in front. I suggest you learn to override that, because this factors as 10 minus 7x times 10 plus 7x. If it is really bothering you that the 7x is at the back of each of those, when you rewrite them, if you were to rewrite those and put the 7s at the front, then one of them has to lead with a negative. And they both end up having a plus 10, because all we've done is switched the order of this. And it no longer looks like it follows the pattern. So it's much better kind of in the long run to fight your brain, to fight that urge, and to just keep it in the same order that it was given to you. So whatever factor is squared at the back, you're going to keep that at the back. Whatever factor was squared at the front, you're going to keep that at the front. Question? Oh, sorry. Helps if I move it up. So sorry. Yeah. Alternately, what I definitely see some folks do is to try to factor the minus sign out. It's all just extra work. It's extra work that we don't need. Just keep the things in the order that they've been written on the paper. Okay, I got one more here. So let's say that I have x minus 4 squared minus 36. And our instructions are to factor this thing. Well, one option is definitely that we could multiply out that x minus 4 squared and then subtract 36 and then get the thing factored. But we don't have to, because this is already in that form of something squared minus something squared. So I can jump straight to thinking about our formula or a shortcut here. So I'm going to have x minus 4 minus 6 times x minus 4 plus 6. Now, both of those, I am going to want to simplify if I can. So inside this first set of parentheses, I've got x minus 4 minus 6, which would be x minus 10. And inside my second set of parentheses, I've got x minus 4. So I've got a minus 4 plus a 6, which leaves me with x plus 2. Question? Usually this screen shows me what's up there, but it's not on today. So I'll do better. I'll do a better job of turning around. Question? Correct, because everything inside of here, it's only addition or subtraction. I don't like have any extra multiplication within the parentheses. So following that order of operations, I want to clean up what's in the parentheses first. So yeah. Just for completeness, let's make sure that we would get the same answer if we did it the other way. So if I didn't see that that was the difference of perfect squares, and I was like, okay, I guess x minus 4 squared, I'm going to have to actually do that. Well, don't forget that x minus 4 squared means that I'm multiplying x minus 4 by itself and then subtracting the 36. Super common mistake, and it showed up on, for some folks on quiz 4. When you have things in parentheses raised to an exponent, that means that you have that thing in parentheses multiplied by itself, however many times. If I have addition or subtraction in here, I don't get to just square the 2 and square the 4. Really, I have to like FOIL out the x minus 4 times x minus 4. So I've got x times x times -4, -4 times x, and -4 times -4. And then we're subtracting 36. If I combine like terms here, I've got x squared minus 8x minus 20. And then I would still have to figure out how that factors. Well, luckily we know how it factors because we just did it the quick way. But let's pretend we hadn't just done it the quick way. And I had to do this from scratch. Now I'm looking for two numbers that multiply to give me -20 and add to be -8. So thinking about my factors of -20 or 20 in general, I could have a 5 and a 4, a 10 and a 2. I think that's it. Well, 5 and 4 could give me a 9 or a 1, right? If I think about addition or subtraction, I could get a 9 or a 1, but I can't get that 8. But 10 and 2, I can get to a -8 if my 10 is negative and my 2 is positive. And I'd end up with an x minus 10 times an x plus 2, which is the same thing we got over there. It doesn't actually matter which way we get through that problem, as long as you have some method to get through that problem. Questions before I move on? Not seeing questions in the chat. Okay. I definitely want to address that there is no formula. There is no magic formula to help us out with something like x squared plus 9. So if I were trying to factor this and think about that as x squared plus 0x plus 9. So I'm looking for two numbers that multiply to be 9 and add up to 0. Well, my only choices for 9 are 9 and 1 or 3 and 3. The problem this time is that in order to get a positive 9, I know that the two numbers I multiply have to have the same sign. So they're either both negative or both positive. So if we thought that it might be a 3, and I thought about that as an x plus 3 times an x plus 3, if we FOIL this out, we end up with x squared plus 3x plus another 3x plus 9. So these middle terms, they don't go away. They don't give me 0 the way they do if one is positive and one is negative. And even if we checked x minus 3 times x minus 3, and we did the same multiplication out, I'm going to end up with x squared minus 3x minus another 3x plus a 9. So again, those middle terms, they don't magically give me a 0. So when I have the sum of perfect squares, it doesn't factor. We have a word for it if something doesn't factor. It's the same word that we use if they're numbers. So if it doesn't factor, we can say that it is prime. Just like we talk about prime numbers. We ready to move on for more fun? Okay. We've talked about perfect squares. Time to talk about perfect cubes. So in general, we don't have a lot of tools for factoring a cubic, meaning something where the largest power on X is a 3. But there are some special cases. And I'm just going to go straight to the formula and then working with the formula, I think. So if I have something that can be written as x cubed minus b cubed, so this is the difference of perfect cubes. This factors as a minus b times a squared plus ab plus b squared. Now I know that looks annoying, and it's slightly annoying to memorize, but it is something that we're going to encounter fairly routinely, both in pre-calculus and calculus. So it's something that we've got to get memorized. Examples of this, I'm going to start. Oh, and you know, just like we did with the squares, this means that it's important that we can recognize perfect cubes. We don't have to recognize perfect cubes quite as high in numbers, but 1 is a perfect cubed because it's 1 cubed. 8 is my next perfect cubed because it's 2 cubed. 3 cubed is 27. That's one we ought to know. Sorry, I wrote squared, I meant cubed. 4 cubed, well, 4 times 4 is 16, and 16 times 4 is 64. 5 cubed is 125. And I'm probably out. I don't actually have 6 cubed memorized. Maybe I do, but I'm probably out except for powers of 2 and powers of 10. I can do powers of 2 a little bit higher, just as I think we're trained from a young age to double stuff. But that's probably that plus 10 cubed being 1,000 are probably the numbers that are going to show up the most often for us. So if I had x cubed minus 8, it would be important to know that we can look at that and recognize that that's the difference of perfect cubes, because that's equivalent to having, well, x cubed minus 2 cubed. So the way that our formula works is that I'm going to square whatever's inside that first set of parentheses now. So I'm going to have x squared. The middle term takes the 2 numbers and multiplies them, or the 2 terms and multiplies them together. So I'd have x times 2 or 2x. And then I'll square the last number. One nice thing about this formula for the difference of cubes, with very rare exception, this thing you get at the back, you can't factor. So once you use the formula for the difference of cubes, you're done. that's the final answer. We don't have to keep looking at it, which I think is nice. We don't have to kind of worry potentially about an extra step. Question. Oh, where the equation comes from?
Well, for applies to the x³.
Yeah, so I've got x cubed minus 2 cubed. So that means my x is my a, and the b is equal to 2. So when we put it in the formula, that should look like a minus b times a² plus a times b plus b². So 2 squared gave me the 4, 2 times x gave me the 2x, x² gave me x². Yep. So let's say that I had 125 a to the 6th minus b cubed. I'm going to go with, if that's where we started, it's starting out a little bit ugly. Stuff's pretty big, so I might do a quick check. Is there anything I can factor out of both terms? But unfortunately there isn't, because I've got a's over here, I've got a b over here. There is no greatest common factor that I can pull out. But I only have 2 terms. I've got subtraction going on. Something is cubed. I'm hoping that I can write this as the difference of perfect cubes. So when I look at that first term, the 125 a to the 6th, I'm thinking, can I write that as something cubed? Because I've already got the b cubed part here. So 125 a to the 6th, I want to be able to write that as something cubed. What's my something? Yeah, 5a to the power of 2. And just as a reminder about those lovely exponent rules, that 5a² to the 3rd power, that's because I can write that as 5a². I don't even need the parentheses. Let me get rid of the parentheses. As 5a² times 5a² times 5a². 5 times 5 times 5 gives me that 125. a², that means each of these is an a times another a. So in total, that's 6 of those a's multiplied together, and I've got a to the 6th. We can also think about it from the perspective of there is only multiplication inside of my parentheses, which means that power can be distributed in because it's only multiplication. I don't have addition or subtraction in there. Okay, now that I'm kind of set up for the formula, our formula says take the first piece, so 5a², subtract the second piece. Then in parentheses here, I take the first piece and square it. So 5² is going to give me 25. a² squared would give me a to the 4th. I add to that my 2 terms multiplied together, so 5a²b. And then at the end, I square the b. It's gross, but remember, we use the perfect cube equation, so I don't have to worry about thinking about whether this factors. I'm just done. That was particularly gross. So that 25a to the fourth, that came from doing 5a squared squared. And this term came from doing 5a squared times b. And this term was just the b squared. Did I make a mistake? Okay. Yeah. One thing that I will just kind of throw out there, all of the things in algebra really do build on themselves. So if you're taking a look at those first 4 quizzes and you're looking at the comments and maybe any mistakes that you personally were making, if you have been having trouble like keeping track of what's going on with exponents, it's going to be really, you're going to want to do some more practice, come in to talk to me in office hours, watch some videos on it. But it's really hard to make this jump if those exponent rules aren't super solid for you. Question. Yep. Oh, like, so technically the coefficient in here is like a 1b. Yeah, a positive 1b.
Plus 5a squared b.
So we've got 2 options how to go back and address that, but the formula as we've got going on at the moment, the formula already accounts for there being a minus sign there. So the formula is already something cubed minus something cubed. And these terms are both positive. I don't know if that helps. So if you want to think about it as a negative b cubed, you would actually be adding a negative b cubed. Let me just do another example that's a little less messy, and we'll see if I get it answered. I'm going to rewrite the formula again, just so that we have it ready at our disposal. So the formula says I have something in parentheses cubed minus something else in parentheses cubed. And that works out to be just the thing in parentheses minus just the thing in parentheses times that first thing squared plus the first thing times the second thing plus that second thing squared. So I'm not going to use A's and B's this time. I'll use different letters. So if this said, I'm going to already have done the factoring for us. If this said 2y cubed minus 4x squared cubed, then this formula, I don't know how well we can see colors, but A is equal to 2y in terms of this formula. And B is equal to positive 4x squared, because that's what's in the parentheses. So on your paper, just go ahead and practice putting all the pieces where they go in the formula and simplifying what you can. So plug the pieces in where they go, simplify if you can. Because we're almost out of time, I'm going to go ahead and finish this off together. So all of these signs are part of the formula. They're already in there for us. We're not doing anything with that. We're just plugging in the A's and the B's. So that first piece should look like my A term minus my B term. Then I need to square my A term. Well, squaring that A term looks like 2y times another 2y. That would be 4y squared. That middle part needs to be A times B. Well, that would be 2y times 4x squared. So if I put that together, I can multiply the numbers together. 2 times 4 would give me 8. But I can't do anything to combine that x squared and the y. And then my last term needs to be b squared. So that's the same as doing 4x squared times another 4x squared. When I multiply the two numbers, I'll get 16. X squared times x squared gives me x to the 4th. So it's gross. But it's a formula. Biggest thing is keeping track of the positive, negative signs in there and making sure that you're correctly squaring out or multiplying and simplifying those terms. Question.
So for the a squared, the 2y times 2y.
Yep.
Do you not add the invisible exponents that are there? Like, you know, how since it's considered 1, wouldn't it be 2y 2? 2y to the second part?
So that is why I have a y squared,
Oh,
because that's a y to the 1 times y to the 1. So if I rearrange the order on that, I can write that as 2 times y times y. Because it's all multiplication, I can switch the order. So the 2 times 2 is what gives me the 4. And you're right, I'm going to add those invisible exponents and get y to the 1 plus 1 or y to the 2.
so don't consider that. Oh. Sorry. I thought for a, like just the part A.
Got it. Yeah. So for this piece, you're just copying down whatever it is. There's nothing you're doing to that exponent.
Yeah.
Yeah. Yep. I am out of time. There is also a formula for when we have a³ plus b³. And I'm going to ask you to read those examples in the book. Because on Wednesday, we're going to be solving equations that involve factoring.